Morning everyone. A very good morning. Shall we begin the session? Today's topic is a trigger, that is a statement. This is a statement that can execute it automatically. Triggers in SQL. So shall we start? In the last class, that is in the Friday's class, we are finished with the schemas, database structures. Now let's start with the trigger. That is a statement that the system executes automatically as a side effects of a modification of database. So whenever there is a modification of a database, whenever there is a changes in the database, that automatically makes the modification to the database. And to design a trigger mechanism, we must meet two requirements. First one is specify when a trigger is to be executed. First point, specify which trigger or when a trigger is to be executed, when the statement is to be executed, and this is broken up into an event that causes the trigger to be executed, to be checked, and the condition that must be satisfied for trigger execution to be proceed. So whenever it is split into the event that causes the trigger that is to be checked out, that is used to the condition that must be satisfied for the trigger execution. Then specify the actions to be taken out when the trigger executes. So whenever we are taking out the actions, we specify the action that is to be taken out or that is to be used when the trigger executes. So one is trigger is to be executed, then the action that is to be taken when the triggers execute. And once we enter a trigger into the database, so once our trigger is entered into the database system takes on the responsibility of executing it. So it's the responsibility of the database system, or that is a responsibility of executing it. Whenever the specified event occurs and corresponding conditions is specified. So whenever it takes out or whenever any event occurs and the corresponding condition is satisfied, that only then the trigger is executed. Then what is the requirement of the trigger? So trigger can be used to implement certain integrity constraints, certain rules, regulation that cannot be specified using the constraint mechanism of the SQL. So this is used to implement multiple technology, multiple constraint, multiple data that cannot be specified using the constraint mechanism of SQL. And triggers are also useful mechanism for altering the humans or for starting certain tasks automatically when certain conditions are met. As an illustration, we could design a trigger that whenever tuple is inserted into the text relation, update the tuple in a student relation for the student taking the course by adding the number of credits, by adding the prices that is to be taken out to the student total credit. As with another example, suppose a warehouse wishes to maintain a minimum inventory of each item. So when an inventory level of item falls below the minimum level, an order can be placed automatically. So it is placed, it is used with the minimum inventory for the system. It is used for the item falls between or below the minimum level. And on an update of the inventory level of an item, the trigger compares the current execution, current inventory level with the minimum inventory level for the same. And if this level is at or below the minimum level, then new order is created out. New rules, new regulations are created out. And note that trigger system cannot usually perform updates outside the database, and hence in the inventory replenishment example, we cannot use a trigger to place an order in the external world. So therefore we can add the order to a relation holding reorders, and we must declare a separate permanently running system that can process out periodically, that scans a relation and places the order. Some database systems also provide built-in support for sending the emails from SQL queries and the triggers, that is using the approach which is used in the trigger SQL, that is the triggers in the SQL. Then there is a triggers in the SQL. So we shall consider the place where the triggers is to be implemented, and the syntax we present over here is defined by the SQL standard, but most of the database implements non-standard versions of the syntax that is used or that are applicable across the implementation. and that shows how the triggers can be used to ensure the referential integrity on the time slot ID attributes of the section relation. And the first trigger definition over here is initiated after an insert on the relation section, and it also ensures that the time slot ID value being inserted is valid or not. So this is valid or not, it is being used. An SQL insert statement will insert the multiple tuples of the relation, and for each row, close in the trigger clause or code that will explicitly iterate over each inserted row. And the referencing new row is used as a clause that creates a variable end row that is used as a transition variable that stores the value of an inserted row after the insertion. And whenever we are using the when statement that specifies a condition that executes the most of the trigger body for the tuple that satisfies the condition. Then begin, atomic, end, close can serve to collect multiple SQL statements into a single compound statement. This is used with the begin and the end. In our example, though there is only one statement which rollbacks a transaction that causes the trigger that uses the trigger for the transaction management. So we are using the transaction management whenever there is only one statement which rollback the transaction that causes the trigger to be executed. Therefore, any transaction that violates the referential integrity rules, referential management rules, that gets rolled back and ensures that the data in the database satisfies the constraint. And it is not sufficient to check the referential integrity on the inserts alone. We also need to consider the updates of a section as well as deletes and update to the reference table whenever we are using the reference table that is a time slot. Then second trigger that is used with the case of the deletes of the time slot ID. This trigger checks out the time slot ID of the tuple that has been created in either which is a position, we can say that is a present position, so that the no tuple in the section contains that particular time slot ID value. Otherwise, referential integrity would be violated. Now, this is one other example of how to create a trigger. So this is create trigger time slot check 1 after insert on section, then referencing the new row as an end row. For each row, when end row dot time slot ID not in, select time slot ID from time slot. So that is not available, that is not present in the time slot. So then begin, rollback, end. Next example, same, that is create trigger time slot check 2 after insert delete on. One is insert on section, then delete on time slot. Referencing old row as O row. For each row, when O row dot time slot ID not in, select time slot ID from time slot and the over or the O row dot time slot ID in, select from section. Then begin, rollback, end. And to ensure the referential integrity, we would also have to create the triggers to handle the update to the sections and the time slot ID. In the same way, we describe next how the triggers will be executed on the updates, how it is used, what are the definition of the trigger, how triggers will be executed to specify the attributes whose update causes the triggers to be executed. And the updates to other attributes would not cause it to be executed. And for example, to specify that a trigger executes after an update to the grade attributes, so we write after update of takes on grade. Then referencing old row as new row can be used to create a variable that stores the value that's storing the old row of updated or the deleted row. Then we use the total credit attribute value of a student tuple that is up to date when the grade attribute is updated for the text relation. This is grade trigger, credits earned after update of takes on grade. Then referencing new row as end row, old row as O row. For each row, when the end row dot grade F end row is not null and the O row dot grade and is not null, begin atomic, update student, Total credit equals to total credit plus. Select the credit from the course where the student ID is equals to enroll.id. And the more realistic implementation of this example would be used or to handle the grade correction or corrections that change a successful completion grade to a fail grade, and then handles the insertion into the text relation where the grade indicates successful completion of the grade. As another example of the use of a trigger, the action on the delete of the student tuple would to check if the student has any entries in the text relation, and if so, to delete them. This is the next example. Create trigger set null before update on text, referencing the new row as an end row. For each row, when end row dot grade equals to space, then begin atomic, set the end row dot grade null, then end. This is the next example for the altering of or for the update of. Create trigger reorder after update of amount on inventory, referencing the old row as a or row, new row as a or end row. And for each row, end row dot level is less than equals to select level from main level, where main level dot item equals to o row dot item. Then begin atomic, insert into orders, select item amount from reorder, where reorder dot item equals to o row dot item. Then end. So triggers can be disabled or enabled, and by default they are enabled when they are created, but can be disabled by using the older trigger name, disable, and triggers that can be displayed or disabled can be enabled again, and that can be instead be dropped, which removes it permanently by using the command drop trigger name. And this is a warehouse inventory example. There's an inventory. There are two items, so there are two fields over here. One is items, one is a level. Then min level, item level, reorder item amount, orders item amount. Which note down the amount of the item to be reordered when its level falls below the minimum. Min level, max level, these are the various items that is to be prepared over here. Now, when not to use the triggers. This topic is when not to use the triggers. So when to use the triggers we have discussed. Next is when not to use the triggers. For example, when we implement the delete cascade feature of the foreign key constraint by using the trigger, so instead of using the cascade, we are using the triggers only. Because this makes the works very simpler, and it is also very easy to implement, but also it would be more harder for the database user to understand the set of the constraints implemented in the database. As another example, when we use with the database, when we use to maintain the materialized view, for example, if we wish to support very fast access to the database to a large number of students that is registered for each course and the section, we do so by creating a relation that is a section, registration, course ID, section ID, semester, EL, total students. That is defined by the query delete course ID, section ID, semester, year, count ID as the total students from takes that is grouped by the course ID, section ID, semester, and the year. And the value of total students for each course must be maintained up to date by triggers on insert, update, delete of the takes relation. Such maintenance may require the insertions, may require the updation, may require the deletion of the tuples for the section registration, and the triggers must be written accordingly to that. However, many database systems also uses the materialized view, but they are automatically supported by the database system. We don't need to write the trigger code again and again for such views. And triggers are also used for maintaining the copies, replicas of the database. And the collection of triggers on insert, delete, or update can be created on each relation to record the changes in the relation that could call the change or the delta relations. And a separate process copies over the changes to the replica of the database that is also used with the modern database system, that is also used with the built-in features for database replication.
Now the next problem that is used with the trigger lies in the unintended execution of the trigger section where the data are loaded from a backup copy or when the database updates at a site are replicated on a backup site. And in such cases, the trigger sections have already been executed and typically it is used or should not be executed again. And when loading the data, triggers can be disabled explicitly. And for backup replica system, there may be a trigger that is used for the primary system. Triggers have disabled initially and also enabled when the backup site after processing has been take place with the primary system. As an alternative, some database system also allows the trigger to be specified as not for the replication. Not for the replication means whenever it is executed, so that is not used for the replication and that is not used for the duplication of the data that is used, but that should check the variable and if it's set, it is true. Both solutions remove the need for explicitly disabling and enabling of the triggers. That should be written with the great care. That should be used with the trigger error that is detected at a runtime that causes the failure of the action statement that sets the set of the triggers. And furthermore, the actions of one trigger can set off the another trigger also. In the worst cases, that should also be used with the infinite chain of the triggering that should support an insert trigger on a relation that is an action that causes another new insert on the relation that is used to insert action that is used to insert an infinity. And that also used with the longer chain of the commands. Longer chain of the commands means whatever the variable that is used with a longer chain that will be avoided with a reference relation. Um, the main Listen, the main purpose of the triggers is to be best avoided when the alternative exists. Yes. Then the next is the recursive query that is not in your course. Recursive queries. Yes. Next is the recursion in the SQL. That is very convenient to specify the transitive closure using the iteration, and there is an alternative approach that used with the view definition that is very easy to use. So we could use the recursion to define the set of the courses that are a prerequisite for a particular or of a particular course, say CS347, and the courses that are prerequisite of CS347 are that is the prerequisite for CS347 and prerequisite for those courses that are prerequisite directly or indirectly for the CS347. And note that for the case 2 that is also recursive since it's defined the set of the courses that are prerequisite in terms of the set of the courses that are prerequisite of CS347. Another example of the transitive closure such as defining or finding out the subparts of a given part that can also be defined in a similar manner recursively. And that can be used with the recursive clause that can be used where the view or the temporary view is also linked out that is also expressed in terms of itself. And the recursive queries can be used, for example, to express the transitive closure concisely that is used or recall with the clause to provide a temporary view where the definitions or whose definition is available only to the query on which it is defined. An additional keyword recursive also specified where the view is recursive. For example, we can find every pair CID free where it says that the free is directly or indirectly a prerequisite for the course CID using the recursive SQL view that could be defined in terms of the union of the two subqueries, that is the base query that is non-recursive and the recursive query that uses the recursive view. And base query is the select of the prerequisite while the recursive query computes the join of the prerequisite and recursive prerequisite. This is the next example of a recursive statement. This is used with the with recursive C prerequisite. And there are two arguments, there are two data items that is use course ID and the prerequisite ID. And select course ID, prerequisite ID from prerequisite. Union, select prerequisite ID, C prerequisite course ID from prerequisite or the C prerequisite. That is where the prerequisite course ID is equals to C dot prerequisite. with the prerequisite ID. Then select asterisk from the C prerequisite, and the meaning of the recursive view is best understood that is used to compute with a basic query that computes all the resultant tuples to the recursively defined view relation prerequisite that is totally initially empty. Then compute the recursive query using the recursive or using the current contents of the view relation and adds all the resulting tuples back to the view relation. And keep repeating the same step until no new tuples are added to the view relation. And the resultant view relation instance is also a fixed point of the recursive view definition that is also fixed in which there is no further changes. And the view relation is thus defined to contain exactly the same tuples in the fixed point instance. And apply to the same logic, apply to the same content with the direct prerequisite of each course by executing the same query once again. It adds one more courses or one more level of the courses in each iteration until the minimum depth of the course prerequisite relationship is reached out. At this point, no new tuples are added to the view and a fixed point is also reached out. That can modify the outer level query that can be used to edify a where clause where prerequisite is equal to CH347. And in particular, when we are using the recursive query, that should not use any following substitute since we are making the query non-monolithic. First is aggregation on the recursive view, then not exist on a subquery that uses the recursive view, and using the except statement where the whose right hand side uses the recursive. And Edexcel also allows certain or the creation of the recursively defined permanent features of views by using the create recursive view in place of the